Okay, good morning. It's our second week to have this class. Okay, so data science for cybersecurity. There's several announcements. Okay, I would like to repeat them again. Make sure you follow those rules or announcement. Okay. Here we have two QR code document. Okay, due to the COVID-19, okay, the university request every student to scan the QR code when you attend the class. So here are two documents, one for undergraduate students, the other for graduate students. Make sure you scan the QR code when you attend this class. Okay. Otherwise, I would know. Okay, if you do not scan the QR code. Okay. Several things need to be here. Okay. Of course, we have grading policy. Okay. 40% of the score will be the homework. Okay. We have several programming exercises and essays. Okay. So you must see the academic integrity section, which I put it right here. Okay. Make sure you understand how to do your homework and write this essay. Okay, 40%. Okay, the second one is project. Okay, you have 20% score will be decided by the quality of the project you made. Okay, students need to write an analysis program on security related data set. Okay, to demonstrate your understanding of security issue and data analysis algorithms or tools skills. Okay, you need to hand in a proposal. Okay, I will tell you when you should hand in your proposal, and a report, which is a document. Okay, describe what is the data set. Okay, what is the problem you would like to solve, what kind of algorithm, technique, tools you use to analyze this problem. And third is the code. Okay, because it should be okay an analyzed program, so you have to hand in your code. Okay, ideally you can upload your code to a GitHub repository so that TA can access your code. Okay, so three things: a proposal. Okay, maybe after the midterm. Okay, you should hand in your proposal, and a report. Okay, a document and a presentation. Okay, depend on how many groups we have in this class. So maybe one student or two students will form a group, and we'll do the presentation at the end of this semester. Okay, and upload your code. Okay, four things, 20%, and still we have midterm and final, 20% for each of them. Okay, so here's the grading policy. Make sure you understand the grading policy. Okay, so it's our second week, right? So here's our schedule, but I would like to say something about collab again. Okay, so make sure you before you enter the first supervised learning. Okay, before you enter supervised learning, make sure you understand how to use collab and what is the difference between you set up your own analyze platform. Okay. Of course, Colab is provided by Google. So first of all, you have to have a Google account. Okay, quite obviously. Okay. So here is an example. Okay, I'd like to show you this one. GPU test. IPYMB. IPYMB stands for Interactive Python Notebook. Okay. So you can simply just click it. Okay, I will show it right here. So simply click the link. Okay, GPU test data IPYMB. Okay, and if your browser has already logged in to your Google account, okay, it should be looks like this. Okay, I will put it right here. It should be like this one. Okay, that's right here. And just wait a second, okay? Okay. If you click the link again, and your browser has already logged into your Google account, it should be look like this. Okay. There are several things you need to understand. Okay, you have to notice the things before you do this. Okay. The first thing is it looks like it just looks like an editor, right? Okay. At the left hand side, okay, at left hand side, there are several tabs. Okay, you may use. Okay. And then I should do this again. The other way, okay, you can simply just type colab.research.google.com, okay, and it shows this interface, okay, and then I open this IPOMV file from my Google Drive, okay, click this one, okay. The interface is the same, okay, either you click on the link or you directly go to colab.research.google.com and open a file from your Google Drive. Okay, it is the same. Okay. One thing you have to before you try to execute those code. Okay, one thing you have to notice is that you can click this small gear right here. Okay, small gear right here. Okay, there are several settings. For example, we want a light thing, a dark thing, or something like that. Okay, it is free for everyone. Okay, however, if you want to pay, okay, there are several features that you can use if you pay Google. Okay? At the right hand side, okay, there are two different blocks, okay, you can use. The first one is called codes, okay. The second one called text, okay. So, for example, if my cursor, okay, is at the very first block, okay, I can simply add codes, okay, it's right here. So you can type your code in this block, or you can click text right here, and you can type whatever you want, okay, make a note or make a comment, okay, right here. Or you can delete those codes, delete those text, okay? And the first things. The second thing I would like to, it's right here. At the right hand side, okay, upper right hand side, here is a button right here. So you can open all those menu, okay? And one thing you have to notice is that, okay, depend on your language, okay? Currently, my interface is traditional Chinese, right? So you can, right here, you can change it to English version. Okay, I think it is much convenient for students who use English, okay? It's right here, help, okay? Now you can change your language. Okay, here's another tab which is very important, okay, before you execute your code, which is runtime, okay? The execution model of Colab is a little bit different from what you execute in your computer. So here I give you a brief introduction how those codes are executed. Okay. So here is internet, right? So somewhere there is a Google server, push. Okay. So I think it should be like this. So it's internet, and there's some certain Google server on the internet, right? So it's you, it's your PC. So you have a browser, right? Just as what we did. Okay, the Google server. Okay, Colab server. So there is a server. Okay. Okay. So on this server, okay, the Google Colab set up a software Colab, right? That is Colab. That is software. Okay. That is software. That is hardware. Okay. For each Colab, okay, when you connect it to a Colab, okay, the Colab will assign a kernel for you. Kernel is a software, okay? Kernel, you can say that kernel is a process that helps you to execute your code. So basically, when you create a new block right here, okay, say, okay, I would like to print something, ABC. You input your code in your browser, okay? So your browser will communicate with the remote kernel, okay, via the internet, okay? So this part of code will be transferred to the kernel that assigned to your browser, okay? So it received print ABC, for example, okay? So the kernel will execute this part of code, okay, right here. So in the server, okay, there should be some CPU, okay, some RAM memory, or even some GPU, which helps you to execute those code. So those code will be uploaded to the kernel, to the Colab server directly, automatically, and execute those code on the remote server on their CPU. So after that, okay, the execution result will be returned. Okay, that is the result. Will be returned to the kernel, and kernel will transfer, okay, those results back to your browser and show your result at the bottom of your next to your code. So basically, your browser, okay, your Colab, your browser is merely just input tool, okay? It's just a GUI tool that accept your code and send a code to a remote Colab kernel, and kernel will execute those code, get a result, okay, and send the result back to your browser, and your browser will show those results next to your code. So basically, okay, you don't use your own CPU, you don't use your own RAM, you don't use your own GPU. The remote GPU, RAM, CPU is provided by Google for free. Okay, for free. So that is the execution model of Colab. So you may leverage these things. So here. So the runtime. So the runtime means there is a setting for runtime. It's right here. Called where is it? Okay. Change runtime type. Okay, this one. change runtime type. Okay. There are several hardware accelerator right here. Okay, here is a drop-down menu. None, GPU or TPU. When you select none, that means your code will be executed in the remote CPU. So the none means the remote CPU. Of course, there's some, if you just simply write a very simple code, you can simply just choose this one, none. Okay. However, if you need to run some AI program, which need a lot of computation power, and you need the help of GPU, you may select GPU right here, so that your code will be executed much faster when you select this GPU. Okay. Of course, there are certain specific device which is designed, okay, specifically for TensorFlow. Okay, you may choose TPU. Okay, if you have any question, just click this more information. Okay, here I would like to demonstrate what is the difference between you use CPU and you use GPU. So I select GPU right here. Okay, and I save this setting. Okay, I wrote this GPU test program. Okay. So just take a look at this one, okay? How do we execute a code right here? So here's my cursor, right? My cursor is right here in this second block, okay? You can simply just click Control Enter, okay, or Command Enter to execute this block. So you can see that there's it's running right here, right? And at the right hand side right here, it's called editing, and how many RAMs you use in a remote kernel, how many disks you use in a remote collab server. Okay, make sure you understand right here. Okay. So if the block has been executed, okay, it will be like this. Okay, so the result will be right here. Okay. The result returned by the kernel will be right here. Okay, in this block, okay, which I print is, I want to know the current version of TensorFlow, which is a very important AI tool provided by Google. The current TensorFlow version, which I use in this collab, is 2.4.1. Okay. After you execute it, okay, all the memories, all the execution state will be stored in the remote server and will kept in the server until you terminate, you close this tab, this web page. Okay, so currently the kernel is up and wait for your next execution instruction. Okay, so the next one is this one. Okay, so I use Control Enter to execute on my keyboard to execute this block. Okay, it's running. So currently, this code will be passed to the remote kernel, and here is the return value. Okay, in this block, I print two different things. Okay, the first one is for the TensorFlow block, TensorFlow package. Okay, I would like to list all the physical device. Physical device right here means what is the CPU or GPU provided by the Google. Okay, so currently you can see that here are some this one. Okay, Google provide me a physical device which is its name is CPU 0. Okay, the type is CPU, and the second one is right here, GPU 0, and the type is GPU. So in this code lab, in this page, I have two devices which can execute my code. One is GPU, the other is CPU. Okay, that is the physical device. Okay, so the other one is the logic device. Okay, here is CPU 0 and GPU 0 as well. Okay, but a difference between physical device and logical device is you can combine lots of physical device to create a logical device. So like you can use 2 physical GPU and combine them into one logical device. And when you run your program on this logical device, okay, it can leverage 2 physical GPUs if you want to do so. Okay, so currently I have 2 device, GPU and CPU. Okay, so I mix here is the node I made for you. Okay, slash CPU, okay, 0, okay, which is the CPU name of my kernel. GPU 0, okay. So in TensorFlow, okay, we both have this implementation. Okay. So I would like to I would like to show you what is the difference between using CPU or GPU to execute your program. So here is a very simple function. Okay, the function is right here. Okay, I randomly, okay, create 2 matrices right here. Okay, with certain size. Okay, and I do matrix product. Okay, matrix product right here. Okay, so I want to get an answer right here. So it's a very simple function. Okay, which is just simply product to matrix. Okay, I'd like to measure how many times. Okay, how many? What is the time spent? Okay, by executing this function. Okay, so I write it code right here. Okay, so when I execute the function, okay, here, okay, line number 7, I ask, okay, to do those computation by using GPU, and the other in line A, okay, by using CPU. Okay, I will not go over all those code. Okay, you can just read those code. Okay, make sure you comprehend those code. Okay, so and here I wrote load right here. Okay, here is the size of that matrix. Okay, from 0 to 500 by 500, 1000 by 1000 to 4000 by 4000. So basically, at the end, okay, I would like to multiplex 2 matrices. Each one is 4000 by 4000. So it is a very large matrix. Okay, so here's the result. The blue line is the execution time of using GPU. Okay, the orange line is the result using CPU. So the x-axis is the size of the matrix. So when you increase the size of the matrix, okay, from 0, 500, blah 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 to 4000, okay, you can see that the orange line, okay, which is the execution time of CPU, is somehow like a linear time span, right? Which means when the size of your matrix is much bigger, increasingly, okay, the time you spend to execute by CPU is much longer. But the relation is like a linear. Because when you do the product computation, okay, GPU has many small small executor on the GPU. Each executor can independently execute the product, so which is much more efficient than using CPU. For each time, CPU has only one executor to do the product computation, but GPU has more than thousands of small executors which can do those execution. Okay, so basically, if possible, okay, make sure, okay, your runtime has changed to GPU if you want to do a large amount of computation. So of course, when you open these things, if you want to try these things or you want to copy those collab file, here is the file, and you can see there's right here. Yeah, save a copy in Drive. That means in your Google Drive, not mine. Okay, you can save a copy in your Google Drive. So you can save a copy and make your own comment, make your own annotation. Okay, so which is more convenient for you. Or you can save it to GitHub if you have GitHub. Okay, you can use GitHub as a code repository. Okay, and there are some other things right here. So here are some items right here. For example, if you like to ask it all the blocks at once, so here is the run all or run before. Okay, if I put my cursor right here in this block and I select runtime, run before, only the blocks before your cursor will be executed. Okay, run the focus cell. Okay, only the cell your cursor state. Okay, run selection, run after. Okay, those are different run time. Okay. Sometimes the kernel in the remote collab server might crash. So at this moment, you can interrupt the execution and restart the runtime. Restart the runtime means kill the runtime kernel at the remote server, and the collab server will set a new kernel for you. Okay, so you but however the execution in the RAM will be disappeared. Okay, restart and run. Oh, okay, there's several settings right here. Okay, that's all. Okay, that is the things before we go to the first. That's right here. Okay. So make sure you are familiar with those collab things. Okay. So before so let's go to the. We'll spend some time in the fourth, okay, the fourth document, which is model. OBS 不见了。Okay, so it's the same. Okay, you can download those documents from my website, and you make a copy to your own Google Drive and try to make some notes. Okay. Okay. We have about 15 minutes. Okay. T04 model, okay, which is a very important topic. Okay, it is a foundation of the entire machine learning and or artificial intelligence course. So make sure you understand what I'm talking about right here. Okay. So the first question, I think you might heard. Okay, so I create a machine learning model. I have an AI model. My model is very good. My model can predict something. My model can do whatever. I think you might heard that. But it's what exactly a model is. That is the question we'd like to discuss right here. And in T04, I will show you a very simple model, which is called a linear model. Okay, it is very simple. Maybe you have learned those things in your when you're in high school. But what exactly a model is? Okay, so what is a model? Anyone would like to make a comment or want to tell us what is model in your mind? 有没有同学愿意稍微讲一下？当我们在讨论到 the translation the translation is 模型哈，对，模型到底是什么？ What is model exactly?
同学要不要试着回答看看？我们不如这样讲好了。模型这个字，在你接触到 machine learning 或 AI 之前，模型原本是什么意思？对，没有错，这个答案就是正确的。模型就是那些玩具啊，飞机的玩具啊，火车的玩具啊，那个叫模型啊。So before you know the word model in AI or in machine learning, when I ask a children what is a model, his or her answer would be, okay, I have a toy, I have a train, I have a flight, okay, I have a small house, which is a toy model, 对吧？这个完全没有问题嘛。好 ，But what is the characteristic of a model？ 就是那这个模型的特色是什么？比如说这个火车，为什么我们叫它模型？比如说这个火车模型嘛，火车模型有什么特色？随便回答，你随便回答一定都对的。对，没错，这就是正确的答案，就是长得很像。What is the characteristic of a model? Which means it is very, very similar to the original ones. No matter it is a flight, for example, a F-18 or a train， 就是一个火车嘛，它要长得非常像。They are very, very similar. So, what is a good model? 那好的模型是什么？随便回答，听是对的。就长得超级像，没错，这是标准答案。When we talk about, I have a very, very nice, very, very good toy model. What I'm referring to the detail, the characteristic of this model is very, very, very similar or very alike to the original one. And we say, okay, that is a very nice, very good toy model. 对吧？这个完全跟大家的印象都是完全符合的，对不对？好 ，So what is a model? In machine learning, okay. Usually, okay, we would like to analyze. Okay, we like to analyze a bunch of data, right? So the target is data. Okay, what is the data we familiar with? The data we're familiar with is the data in a table, or the data in your Excel, right? So here is the data, the first data, the second data, the third data. Okay, for example, we have n data, n rows of data. Okay, how do we describe those data? We have several different columns, right? For example, the first column, okay, I use this symbol X, the first column, the second column, third column. Okay, assume we have n columns to describe our data. For example, if I would like to describe the children, okay, the children in elementary school, okay, in elementary school, I would like to describe a kid, okay? So I have n columns to describe a child. What field, okay? List things, what we call feature. Those columns is what we call features, okay? So we have n features to describe children, okay? But we can, for example, maybe that is the height, okay? Maybe that is his weight. Maybe that is his eye color, and so on and so forth, okay? I can use several different columns, several different features to describe a kid in the elementary school, right? Okay. But what
why it's related to a model? Okay, so that is it, the interesting things. Usually, when we get a bunch of data, okay, we have a specific problem need to solve. Okay, and usually, okay, I say usually the problem is related to prediction. Okay, it is just one of the problems we would like to solve. Okay, for example, here is another column which we call target, and its notation, its symbol is Y. Okay, it's Y. Okay, so for this problem is that I use n columns, n features to describe a kid, which is an entry. Okay, usually that is called an entry. Okay, the first entry. And here's the problem. I would like to use these n features to describe this kid. So basically, okay, we use another notation. It's right here. All those n features, we use another symbol, which is the X, okay, big X. So we have two, we have two slash right here. Okay, that's called big X. Okay, I use this big X to describe my data, which is a kid. Okay, and before we make this model, okay, another important question is that what is the best model of something? 中文就是说，如果要叫你做一个最好的模型的话，那个最好的模型会是什么呢 ？For example, if you have a toy model, for example, airplane, okay, an airplane. What is the best airplane model of this airplane? 好，还有绕口哈。如果我有一个飞机的模型的话，那这个飞机的模型最好、最棒的那个飞机模型会是什么呢？同学有一个同学，好像棕色衣服的那位同学，问咖啡色衣服，最好的模型是什么？随便讲。啊，最像的，那谁最像？对，这是正确答案。The best model of something is exactly something that itself， 可以吗？最好的模型是什么？最好的模型就是他本人呢、对不对？所以如果我说我有个好棒的飞机模型，就是刚好就是飞机原本的那个人，所有的细节都在的，所有的证据，所有的那些可以动的东西啊，那些参数，所以都是一样的。我就不需要做一个假的东西来描述它了嘛，对不对 ？So the best model of something is something itself. So if here are some data, this data, right? So if I want to create a model of this data, right? What is inside this data? There are n rows of data. For each row, I have n columns to describe this n data. And okay, we just simply ignore y. Okay. So the best model, I would like to describe this a bunch of data. How do I describe this data? The best model to describe this data is the data itself. So if I would like to preserve all the details of this n data with n features, I need a space which is n y. So if I have a space which is n by n, so that I can preserve the entire data set of this data, so that I don't need a model to describe, because I can preserve all the information in this data set. So that is the best model, because the best model is the data itself. Right. However, when we talk about data analysis, how much data we are talking about right here? Usually thousands, 10,000s, millions, billions of data we are talking about when we analyze a very large amount of data. So you need a very, very large memory or storage to store billions of data, billions rows of data. Okay? When we talk about the features right here, what is the order of these features? Usually hundreds or thousands, but even more, 10,000s of features to describe the data. So if you want to take this strategy to preserve all the data, all the information in this data, you need a very, very large storage or memory to store this data so that you can keep all the information. So you don't have to you don't have to use a small model, a compromised model to describe this data. However, n by n is very, very large. So in practical, we will try to use some mathematical methods to help us to preserve those data, to characterize those data, just as the toy model does. 就跟玩具一样嘛，你就是大概有形塑它很像的一个外表就好了，对不对？你不需要把所有细节记下来。So that is what we do. So the model means I would like to create a model. The model can use the X, big X, to describe the original data. Okay, that is model. However, most of the time, when we talk about data analysis, usually we have a target. What does the target means? That means, for example, if it is a kid, right? That is a kid in an elementary school. That is, okay, for example, here we have a very specific prediction application, which is the salary. If we make the data, okay, we preserve all the information of this kid when he or she in the elementary school, okay, the height, the weight, the eye color, the score, the GPA, the whatever, a lot of information of this kid, okay, and the application is I would like to know what is the salary of his or her first job. Okay, you can collect such kind of data, right? You can collect such kind of data. So the problem is that could we use the big X to predict Y? Okay, that is the application we want to use. So of course, you can collect a lot of data, okay, from for example n data, okay, n features, and collect their when they grow up, okay, collect their first salary, annual salary, okay, and put it in the Y column. So the model is there is a very specific application I like to predict Y by using big X. So that is the things. And the model that we talk about is if you want to preserve all the data, which is fine, then you need an n by n plus 1 to preserve all the information. However, we don't have that much space or memory to store all this information. So we need the help of mathematics to help us to create a more simplified model to describe the information between big X and Y. Okay? So again, okay, I said it again. The best model is the data itself. However, we don't have enough memory or storage, so we don't preserve all the information. So we need some statistic or mathematical method to help us to characterize the relationship between big X and Y. So here in this class, okay, we will teach you what is the mathematics methods to help us to describe the relationship between X and Y. Okay? So here, okay, we have data size here, we have level features, target. However, it's right here. If I have a model, okay, called M1, okay, because we have several different mathematics methods to help us to create those models, so I use M1. For example, I have a model M1, okay, it can predict Y from X. However, we say it's a prediction, right? It's a prediction. Maybe the model is not that good. As we mentioned, a toy model only characterizes some basic things, okay? It does not describe all the entire detail of the airplane or the train, right? So basically, the output is what called Y hat, okay? Is the predict value. It may not necessarily exactly the same as Y. Y hat is not necessarily exactly the same as Y. It depends on how good your model is. If your model is very, very good, it's good enough, the Y hat will be very, very, very close to Y. If your model is too simple, okay, too simple, the Y hat might be a little bit far away from the Y because your model is not good enough, just like your toy model, okay? So Y hat is the prediction value, okay? Okay. There are several questions about using this metrics, okay? First one, data size is large or small? 等一下，已经打中了. Okay, let's start right here. Okay, we'll talk about those problem next hour. Okay, we take a 10-minute break.